Hi Geometry class, we are going to be looking at section 1.4, applying triangle sum properties. And in this new chapter, we're going to be looking at triangles. It's all about triangles and proving two triangles congruent to each other. But before we get into proving triangles congruent, we got to learn a little bit about our triangles that we are looking at. So we're going to be looking at finding angle measurements inside these triangles, and also outside we have interior and exterior angles. And then we're going to be applying theorems about these interior and exterior angles of our triangles. So let's go on. All right, before we get into classifying our triangles in the next examples here, we are going to look at classifying each angle as either acute, obtuse, or right, because these words actually follow us over into classifying triangles by their angle measurements. So on number 1, you can see that this angle has a little right angle symbol right here, so that is going to be a right angle. And this one over here, number 2, this has a 40-degree angle, which is less than 90 degrees, so that is an acute angle. And then this last one, number 3, we have an angle measurement of 150, that's greater than 90, so this is an obtuse. Okay, so remember these definitions when we go to classify our triangles here in a minute, because they follow us over into it. So here's our vocabulary for this section here. Quite a few words, but like I said before, a lot of our words carry over from previous things we've learned. So let's get started on them. Recall that a triangle, we're going to use this little symbol that you see right here to denote triangles. Like when we write triangle ABC, like we see here, we're going to write triangle ABC. Oops. Here's C. There we go. This is the name of this triangle right here, and this is how we're going to name it, triangle ABC. And then it says triangles can be classified in two ways, by their angle measurements or by their side lengths. And that is the next thing we're going to be looking at. Before we move on to that, though, to kind of tell you a little bit more about triangles here. These triangles have sides. All triangles have 3 sides. They're all made up of segments that we name just like this right here. So we have segment AB, this one right here, BC over here, and AC. Okay, I want you guys to learn how to write your side lengths and triangle names properly. So please follow along just like this and like this. Now, we also have vertices of a triangle. Those are our angles of our triangles. So vertices A, B, and C are where our two segments come together. Okay. Now here's the classification by angle measurements. So looking at all of our angle measurements in our triangle, we can see that all of these angles are going to be less than 90 degrees. So when all of our angles inside our triangle are less than 90 degrees, that means we have 3 acute angles, calling this an acute triangle. Whenever all of our angles are the same measurement, then we have 3 congruent acute angles, and we call this an equal angular triangle. Now when we have just one right angle inside our triangle, like is shown here, this is called a right triangle. And now when we have one obtuse angle, like we have right here, we can tell that that is bigger than 90 degrees. This is called an obtuse triangle. Now, in this first example, we're going to be classifying our triangles that we see in this picture by their angle measurements. So, let's look at this. First, we're going to look at triangle FHG. So, FHG, this one right here. We can see that all three of these angles are going to be acute, but they're all three, if we found this angle measurement right here, from what is left over of 90 degrees, that is going to be 60 degrees. So, this right here is an equal angular triangle. So let's name triangle FHG. That is equal angular. Now the next triangle, let's go on to it, GHE, which is right here, GHE. This is the whole big outer triangle. Well, I see one right angle over here, which makes the triangle a right triangle. So equilateral triangle, right triangle. Now our last one that we're going to name is EFH. So let's find this triangle. So EFH. EFH, you can see that from knowing this entire angle measurement is 180 left over from 100, after subtracting 60 from 180, we have 120 degrees. Well, that there is an obtuse angle. So, we are going to name this an obtuse triangle. And there you go. There's some of our angles and which help us classify our triangles. Now let's classify triangles by side length. Let's start out with an equilateral triangle. An equilateral triangle, all three sides are going to be congruent, like is shown here in this picture. Remember, these little markings right here mean that they're the same. They're congruent. Okay? So, three sides congruent, equilateral. Now, if two sides are being shown congruent, that means we have an isosceles triangle. Okay? So, two sides are being shown congruent right there. In a scalene triangle, no sides are congruent, so you're not going to see any markings of any kind on scalene triangles. You may see something like this right here showing that no side is equal, something like 6, 10, 12, something like that. None of these sides are congruent, so it's a scalene triangle. Okay, on this example 2, I'm going to ask you again to classify the triangles, but by side length this time. So this first one, right here we have triangle ABC. These two side lengths we can see are congruent to each other because they're both 5 centimeters. This side right here is 4 centimeters, so this isn't going to be an equilateral triangle, it's going to be an isosceles triangle because two sides are congruent. So let's spell this. Isosceles. There you go. And then this triangle over here, where you see 13, 9, and 14 as side lengths. None of those side lengths are equal to each other. So this is going to be a scalene. triangle. Now this last one, you see that they have angle markings in it, but you also see that they have markings of sides saying that these are congruent. Well, whenever you have an equilateral triangle, you have an equal angular triangle, and vice versa. And this is only true with triangles. Any other polygon with sides, like say a four-sided polygon, it's a quadrilateral. The only time where you have equal angular and equilateral is inside a square, but a rectangle is not equal angular and equilateral. There's many other sorts of quadrilaterals and other sorts of shapes that all sides are not going to be congruent and all angles are going to be congruent, like in a triangle here. So just remember that in the future, that a triangle, if it's equilateral, it's also equal angular. But let's spell this out. This is equilateral triangle. There you go. Okay, in example 3, we're going to classify these triangles again, but by angle measurement and side lengths. So you can see that I have titled already that these 3 triangles are scalene triangles, and these 3 are isosceles triangles. But we can also add in what type of classification they are by angle. We already know side is going to be scalene, and these are isosceles. But this is how we're going to add them in. A, right here, triangle A, all angle measurements are acute. You can see that they're all going to be less than 90 degrees. So this is an acute triangle, but it's an acute scalene triangle. In this next one, in B, you have a right angle, so it's going to be a right scalene triangle. And the last one, C, this angle right here is greater than 90, so you have an obtuse scalene triangle. All right, triangles D, E, and F are isosceles, and you pretty much do them the same way. You can say this isosceles for triangle D is an acute isosceles. I don't have enough room to write this. Let's see. Whoops, S. Let's write that again. Okay, so E here, I'm going to write up here, E is a right isosceles triangle. And then F, this angle is greater than 90, so we got an obtuse isosceles. Okay, so that's how you classify them by side and angle measurement. Okay, one of our theorems that we're going to be looking at in this section here, and that's going to be following us through this whole chapter, maybe even the rest of the school year, is this one right here, the triangle sum theorem, this which states the sum of the angle measures of a triangle is 180 degrees. So all of our angle measurements in our triangle are always going to add up to 180 degrees. So let's look at this example, number 4. It says find the missing angle measurements. Well, we don't have angle W. We'll find it. We do not have angle X, or WXY is what that one's going to be called. And we do not have this one here. That is XYZ. So So we're going to find all three of these using this right here. So, measurement of angle XYZ. That's the one I marked up here with 3 angle markings. How are we going to find that one? Well, we have this triangle right here, XYZ, has 62 degrees and 40 degrees already inside 2 of the angle measurements. So subtract those from 180 degrees, and that is using the triangle sum theorem. So say 180 degrees minus our 62 plus 40, and we have 78 degrees. So our angle measurement for XYZ is 78 degrees. Let's find the next one, the one that I have marked with a double angle marking. This is named WXY. And again, we can find this one by using that the whole line right here is a measurement of 180 degrees. So this whole thing adds up to 180 degrees. Subtract. Okay, so knowing this fact that these two angles add up to 180 degrees, we could say, 180 degrees minus our 62 is going to give us our measurement for WXY, which is 118. Now the last angle measurement we don't have to name with 3 angles because it's defined right here just by itself by W. Measurement of angle W. Well, now that we have this angle measurement inside our triangle here, and we have this little angle measurement is 12, we can subtract that from 180, again using that triangle sum theorem, and get our angle. So, again, 180 degrees minus our WXY angle measurement, 118, and our little bitty measurement of 12 degrees, and we have a 50-degree measurement for that angle. And we're done. Let's find another example. Here are the definitions that you need to know for interior angles and exterior angles. Remember that an interior angle is formed by 2 sides of a triangle. The angle that's on the inside, that is the interior angle. Makes sense, right? So, an exterior angle is formed by one side of the triangle and the extension of an adjacent side. So, like you see, angle 4 right here, that is what this is describing up here. This right here, angle 4, is an exterior angle. Okay, so let's look at this a little further. Here's a theorem about exterior angles. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. Okay, so what this means is angle 4 here, just following this right here, angle 4 is equal to the addition of these 2 angles. Okay, so that's how we're going to find our angle measurements in this next example. So it says in this next example, find this right here, find measurement of B in this triangle. Okay, so we can do that by using the exterior angle sum theorem to help us in finding what x is equal to. So that's what we need to do first. Exterior angle sum theorem says add together measurements 1 and 2, set it equal to 4, and solve. So 1 and 2 are right here, and then angle 4 right here. Set it up properly, you have 15 plus 2x plus 3 equals 5x minus 60. Now solve this equation for x. And when you solve, you get 78 on this side is equal to 3x. So x is equal to 26. Now that is not exactly what we're looking for. We're asked to find a measurement of angle B. So let's keep going. Measurement of angle B is right here. And how we're going to find that is we're going to plug in our x value. So measurement of angle B is equal to 2 times 26 plus 3. And let's see what we get. What we get is 55 degrees. Okay, so that's how you answer that part of the example. Let's look at this next part. We're asked to find, in this triangle right here, find the measurement of ACD, which is the exterior angle. Okay, we do that much the same way we did the last one. We need to find what Z is first. So what we need to do to set this up is say our exterior angle is equal to this angle plus this. So we're going to say 2z plus 1 plus 90 is equal to 6z minus 9. Solve for z. Get 100 is equal to 4z, and z is equal to 25. Now plug that back in to find the measurement of ACD into the 6 right here, the 6z minus 9. So 6 times 25 minus 9, that is equal to 141 degrees. So that is using the exterior angles theorem to help us find angle measurements. Okay, so a corollary, that's what these next two types of theorems are. It says a corollary is a theorem whose proof follows directly from another theorem. So here are two. We have this corollary that follows the triangle sum theorem. It says the acute angles of a right triangle are complementary, which is true. Since a triangle only has 180 degrees inside the triangle, the total triangle angle measurements, well, then if this is 90 degrees, what's left over from 180 is 90 degrees. So the addition of our other two angles together equal 90. So they're complementary. And then this next one, the measure of each angle of an equal angular triangle is 60 degrees. So this is always going to be true if we have an equal angular or even an equilateral triangle. All angle measurements are going to be 60 degrees. So following those corollaries, we have this example here, which states one of the acute angles in a right triangle measures twice the other angle. What is the measure of the other acute angle? So I'm going to draw a picture of what we have here. Whoops. Let's get my drawing tool. Okay, so we have a right triangle. So we know one of them is 90 degrees. The other two angles, this is the other angle, which measures x degrees, and the other angle is twice the other, so 2 times x. Now, we need to find what the angle measurements are. What is the measure of the other acute angle? What is x? So this is what we're going to be doing. The corollary stated that these two angle measurements in a right triangle, other than the 90-degree marking, are going to be complementary. So they add up to 90 degrees. So 2x plus x equals 90. Get 3 here equals 90. And then divide by 3, we get 30 degrees. So x here is 30 degrees. And if we were asked to find the other angle measurement, this one right here, what we would need to do is just say multiply that by 2. So the angle measurement for here, that would be 60 degrees. So here was 30. And we're done. So this is actually the last thing I have for you all, and I will see you in class. Goodbye, everybody.